the derivative of tan inverse of x. So suppose we don't know the derivative of the inverse tan function. We do know the derivative of tangent x is secant squared x, and the derivative of tangent u is secant squared u times u prime. That's the generalization using the chain rule. So we will follow the same procedure. We will start with saying y equals tan inverse of x. That's the function we'd like to differentiate. We change this to say tangent of y equals x. And again, let's think about that. Tangent of y equals x over 1, essentially. And so that means we have an angle of y in our right triangle. Its tangent is x over 1. So it means x is the opposite and 1 is the adjacent. And of course, if these are the two sides of the triangle, then the hypotenuse would square both sides, add them together, take the square root. So the hypotenuse is the square root of x squared plus 1. So now that we've analyzed the triangle, we will take the derivative of this function. So the derivative of that function is secant squared y times y prime equals 1. And so y prime equals 1 over secant squared y, which is cosine squared of y. We'll go back to the triangle now. We know that the cosine of y is 1 over the square root of x squared plus 1. So the cosine squared is 1 over x squared plus 1. And that is the derivative of the inverse tangent function. So, derivative of tangent inverse of x equals 1 over x squared plus 1.